In this section, before I jump into it, we have to remember a bit of geometry. And the geometry that we have to remember is how to find the area of a trapezoid. And I'll draw just a standard trapezoid here. I guess you'd call this a regular trapezoid. And the area formula for a trapezoid is the height times the sum of the bases divided by 2. And the trapezoid that I have pictured, it actually doesn't have a height drawn in. To be a trapezoid, you need 4 sides. You need one set of parallel sides, and the other sides don't have to be the same. They can be the same, but they could even go in slightly opposite directions. In this particular problem, we'd probably say this lower parallel side is base 1. The higher parallel side is base 2, but you can call those differently. And then the height is generally a line that connects the bases that's perpendicular to the bases. So this would be the height. And if I wanted to find the area for this particular trapezoid, I'd have to attach numbers to these. Let me say base 2 maybe is like 4 centimeters. The height maybe is 3 centimeters. Let's say base 1 is 8 centimeters. These probably aren't even to scale, but if I was given the task of finding the area of this trapezoid, I'd need the formula. I'd go area is height, which is 3 centimeters, times the sum of base 1, which is 8 centimeters, plus base 2, which is 4 centimeters, all over 2. And then I'd add inside the parentheses, and when you're adding, you don't get square units. It's when you multiply, you start getting squares. So 4 centimeters plus 8 centimeters is 12 centimeters. Now in the numerator, I'm going to multiply, and when you multiply the numbers and the units. 3 times 12 is 36. Centimeters times centimeters are square centimeters. And then if I divide the trapezoid that I drew, is going to have an area of 18 square centimeters. In terms of when we get into the section, the trapezoids that we're going to need to find the area of, they're still trapezoids, but they're oriented a little bit different. So just to get the connection to our section, I'm going to draw a trapezoid on an XY axis, because all the trapezoids that we're going to be given are going to be drawn on a nice XY axis. Let me mark some numbers up here. Oh gosh. So in some sense, or well, in every sense, this is the 0.15. This is the 0.34. And I've drawn a trapezoid here because it has parallel sides. And the parallel sides are always the bases. The line that's perpendicular to the parallel sides is the height. And for this particular trapezoid, this is actually the height, the distance between x equal to 1 and x equal to 3. This is a line that's perpendicular to the parallel sides, so it's actually a height. And for my particular trapezoid here, the height is going to be 2. I can just subtract 3 minus 1 to get 2. Base 1, if I call this base 1, has 1, 2, 3, 4, 5. This is 5. The length of it is 5 units. I'm not going to put units on because we're not going to use units in this section. The height of the base, when a trapezoid is drawn on the x-axis, the bases are going to have the length of the y-coordinates. This base 2 right here, this side goes from the bottom of the x-axis, or goes from the x-axis that has a y-coordinate of 0 to the point 3, 4 that has a y-coordinate of 4. And if you counted, there's 1, 2, 3, 4. The base 2 has a length of 4. So the y-coordinates of the points, if a trapezoid is resting on the x-axis, are going to be the length of the bases. The height's going to be the difference between the x values. So in this particular trapezoid, my area is going to be the height, which is 2, times base 1, which is 5, plus base 2, which is 4, all over 2. And then I could cancel the 2's now, would be good to do. If I didn't cancel the 2's and went through all my multiplication, you'd still get the same number. So the area of this trapezoid is 9 square units. If I would have canceled right there, I would have gotten to the 9 square units a little bit quicker. So that we need to be able to do. We need to be able to calculate an area of a trapezoid. We're trying to make the connection between calculus and geometry at this point, and that's where section 5.3, what 5.3 attempts to do. In section 5.3, there are only 10 problems, so it's short-ish, but they take a long time to do because there are a lot of parts. In section 5.3, what we're going to do is we're going to try to estimate the area of a shape that doesn't have straight edge sides using trapezoids. And we'll either overestimate or underestimate the area with our trapezoids, and then I'll make the connection between areas with trapezoids and areas with calculus. With geometry, you can only calculate the areas of kind of perfect shapes, circles, ellipses, any polygon that's has multiple sides with straight edges. You can do the area of exactly, but you can't in geometry find the area of that because it's not a regularly shaped shape. In order to find the area of that with geometry, the best we could do is cut this up into pieces, really small pieces, and find the area of each one of those small pieces and add those together to find an estimate of the area. And that's kind of what we're going to do in this section. I'll try to draw better pictures to explain that as we get deeper into this section. But you can't with geometry find an area of a shape that has any irregular sides. If it had all irregular sides, you couldn't find the area of the shape either. Most of the shapes in our class that we're going to be wanting to find the area of aren't that, they'll have multiple regular sides and one irregular side, which makes them a little bit easier to do than something that's a blob like that. But in order to find an area of a figure that has multiple irregular sides and irregular sides, it takes integrals or antiderivatives to find the exact area. And you can't find the exact area with just basic geometry formulas. But we can estimate an exact area with geometry. We can't get an exact area. So each of the problems in this section, we're going to sketch a graph, and we're going to use trapezoids to estimate the area between the area of the figure that we're going to draw. And then we're going to compare that estimate to the exact area that we can get by calculus. And each problem has a boatload of steps. If you opened up section 5.3, you saw something that looked like this. So there are 10 problems, which makes it look encouraging, but each problem has G steps, and I don't know how many that is, but more than I care to do. I'm going to try to walk through the problems and just explain what I need to explain to make the connection between geometry and how we can use geometry to estimate what we can get with calculus, and just kind of see where it goes. So if you just read these steps right now, they might not make too much sense to you. So let me just try to make the problems make sense. So problem 2 is my first even problem that I'm going to make a stab at doing. And if I look at my steps, step 1 is use your calculator to create a graph of the function. So I need to create a graph of the function 40 over x. I'm going to make my graph top heavy as opposed to bottom heavy because all the y coordinates, all the points are going to be in the first axis, first quadrant. When I make my graph, I'm going to need to be aware of a little more what's going on in the problem. So I'm going to make y1 the function 40 over x. Very specifically, I'm going to make my x min and my x max. Just look at the portion of the graph that it's called out in the problem. And as I do more of these, it's going to be more obvious what region of the graph I'm calling out. So I'm going to look at this graph, and I'm only going to draw it between x equal to 2 and x equal to 8. And then in a second, I'll worry about this. This little blob here, using 2 intervals, tells me I want to draw 2 trapezoids and find the area of 2 trapezoids to estimate an area. And let me do some more drawing before I get to my calculator. So right now on my x-axis, I am only going to write the numbers 2 and 8. If I start writing more numbers, it's going to make it hard to follow. 3, 4, 5, 6, 7, 8. So I'm going to graph the function 40 over x with x min equal to 2, x max equal to 8. So y equals clear 40 divided by x, window x min 2, x max 8. I'm going to leave my y's at the negative 10 to 10. If I can see the graph doesn't go off the screen, I'll be content with those y's. If my graph goes off the screen, I can't be content with those y's. So when I sketched my graph, it goes off the screen. So I need to figure out what the y's should be. If I just take this value of 2, because it looks like if I take this value of 2 and do second calc value and type in 2 and hit enter, it tells me that the y value of the point that has an x coordinate of 2 is 20. And that doesn't show on a window that only goes up to y equal to 10. So my window isn't high enough because the y max wasn't high enough. I need to go to a number bigger than 20. I'm going to go to 30 just to be safe. And this is the graph. This, again, this is not the x-axis here. This is x equal to 2. So now I'm going to copy this graph. I need to copy this point exactly and that point exactly. So I'm going to go second calc value, type in 2. The first point I'm going to draw is the point 220. That's the far left edge point. And then I'm going to type in the number 8 and hit enter. And the last point I'm going to draw is the point 85. So I have the point 220, the point 85, and I'm going to copy exactly what I see here. More or less like that. My graph has a slightly different window than I have drawn here, so they're both fine. It has the same shape. It's good enough. So what my goal is to find exactly, I'm going to shade it in for you. This is my goal. My goal is to know exactly what the area is above the x-axis below the graph of y equals 40 over x between x equal to 2 and x equal to 8. This is my goal, is to find this area. And with geometry, because this doesn't have straight lines, it has a curved line, I can't do geometry to find this area because geometry doesn't deal with shapes that have some straight sides and some curved sides. There's no shape like that that I can find the area of. That's my goal, is to find that area. Ultimately, I'll use calculus to find it, but we're going to estimate the area. So I'm kind of through step A, on my calculator, I've created a graph of the function, and I labeled a couple points. Step B is going to help me finish out the x-axis. It says subdivide the x-axis into n intervals. I need 2 intervals on the x-axis because I'm going to make 2 trapezoids because it says to make 2 intervals. In order to get 2 trapezoids or 2 intervals, I need 1 more number on my x-axis, so I could make 3 numbers on my x-axis that'll allow me to get 2 intervals. And how do I get the numbers on my x-axis? I subtract the x-coordinates of the points, divide by the number of intervals. So to get my spacing on my x-axis, I'm going to go x2 minus x1 over n. So this is kind of finishing up, subdivide the x-axis into n intervals. And I need to get my x-axis into 2 intervals. Right now I just see the interval from 2 to 8, so there's just 1 interval there. I'm going to figure out where to put another number so I can get multiple two intervals. And now to do that, I'm going to take x2, which is 8, minus x1, which is 2, divided by n intervals, which is 2. This is going to be 6 over 2, which is 3. That means starting from 2, every 3 units I need to put a number on my x-axis until I get to the edge. So starting at 2, going 3, 4, 5, put a number on my x-axis, and then 6, 7, 8, I'm at the edge of my point. So now, in some sense, I've subdivided my x-axis. There's an interval from 2 to 5 and an interval from 5 to 8 that are implied there. Those are the 2 intervals that are implied. Now, evaluate the function at each value marked on the x-axis. Well, I've evaluated at 2 and 8 already. I need to evaluate it at 5. And I'm going to get the point 5 comma something, and I do that by going second calc value, typing in 5, and at 5 it's at 8, and that almost looks reasonably well. So done with step C. So a lot of my work is all being shown on a single graph. A's on the graph, that's just the graph itself. B are the numbers on the x-axis. C are the y-coordinates above each point on the x-axis. D, I'm going to draw on the graph too. Draw trapezoids implied by the points. So my first, I should get a different color. I don't know, maybe even a pen or something. I need something different to write with. Otherwise it's not going to show up like I need it to show up. Not sure that this is the right pen. Let me try this pen. What I'm going to do is I'm going to draw a trapezoid. I'm going to make these the bases and connect these points and draw a trapezoid, and connect these points and draw it. So there's 2 trapezoids kind of drawn here. This is my first trapezoid. It goes and when I calculate the area of it, it's going to estimate the area that I have in pink here, and it's going to overestimate it because it's a little bit higher because the curve kind of bends in. So let me try to calculate. Well, I'm done with step D. I've drawn the trapezoids. Part E, I want to find the area of each trapezoid. So here's kind of a trapezoid 1 and a trapezoid 2. For each trapezoid, I want to find the area. So I'm going to look at trapezoid 1, and this distance right here is the height, which is 3. So the height equals 3. This is going to be my base 1. And my base 1 is going to be it's going to be 20 units long. It's always going to be the y coordinate of the point that it connects to. This is going to be my base 2. And its length is the y coordinate of the point that it connects to, which is 8. So the area of trapezoid 1 equals the height 3 times base 1 20 plus base 2 8, not that it looks like an 8, but it's an 8, divided by 2. So the area of trapezoid 1 is 3 times 28 over 2. Makes it easier if I cancel, if I'm not doing this on my calculator, so I'm going to cancel those and get a 14. And then 3 times 14 is 52. So the area of trapezoid 1 is 42, should I say. 3, yeah. It's 42 square units. Now I'm going to move on to trapezoid 2. And the height is the distance between it's this length right here, and it also has a height equal to 3. For this one, its base 1 is going to be 8. So now it's going to turn into a base 1, and the base 2 is going to be 5. So we'll just call that now a base 1. So for trapezoid 2, when I do the area of trapezoid 2, the height is 3. Base 1 is this 8. Base 2 is this 5. I'm going to divide by 2. I'm going to get a decimal. It's not the best. I can live with it. So this is going to be 3 times 13 over 2. And I'm going to go to the main screen and get a decimal for that. So second quit. 3 parentheses 13 divided by 2 is 19.5 square units. So the area of trapezoid 1 is 42 square units. The area of trapezoid 2 is 19.5 square units. That's the end of part E. So all this right here, sorry, I blew that away too fast. This is for two part E. My graphs are going to be A through D. So for 2, A through D, they show up on the graph. Part A, sketch a graph. Part B, put numbers on the x-axis. Part C, find the y values. Part D, draw the trapezoids. That's all in the graph. Part E, find the area of each trapezoid. I just did in these 2 columns. Part F, add the individual areas together to get an estimate of the area under the curve. So for part F, I'm going to add the area of the first trapezoid plus the area of the second trapezoid, and that gives me 61.5 for an estimate of the area that I shaded, but it's an overestimate because the trapezoids are slightly taller than the area that I'm trying to find, and geometry can never give you an exact area to an irregularly shaped object. That's what part G is going to do for us. Part G, my calculator has the ability to find this exact area without these little overestimates that trapezoids give me. So what I'm going to do now is part G, I'm going to use the integration or antiderivative ability of my calculator to find the exact area. So how do I do part G? I go get the graph back on, go second calc, go down to option 7, which is our nice antiderivative symbol. Tell it where you want to start finding the area, and I'm going to start at x equal to 2. Hit enter. Tell me where I want to end. I'm going to end at x equal 8 and hit enter. And this is the area that it's finding. It's finding that exact area as opposed to using trapezoids and slightly overestimate the area. So the exact area round to 2 decimals, I'm going to round everything to 2 decimals in this section, is the exact area. Instead of 61.5 square units, is 55.45 square units. So each of the 10 problems that we're going to do between in section 5.3, we're going to do exactly the same steps. So the steps aren't going to change, just the functions might change from problem to problem, or the number of intervals might change from problem to problem. We're going to do exactly the same thing. We're going to use my calculator to sketch a graph. I'm going to put 2 numbers on the x-axis to start, and then I'm going to fill up the x-axis with more numbers. And then for each number on the x-axis, I'm going to get a y value. Then I'm going to draw trapezoids, find the area of the trapezoids, and just go on. So there's no reason I have to only make 2 trapezoids to estimate my area. It turns out that the more trapezoids you use to estimate your area, the better your estimate's going to get. So my estimate's 6 units off, or 6 square units off. The area of my trapezoids are bigger than the actual area by 6 square units. If I took this same function, the exact same 40 over x, and made 4 trapezoids as opposed to 2 trapezoids, we're going to find that our area estimate is going to get a lot better. It's instead of being off by a factor of 6, it might be off by a factor of 1 square unit or 3 square units. The more, and I'll try to show you visually why that happens, but the more trapezoids we use to estimate an area, the better our estimate is. So let me do question 4 using the same steps. So step A, I'm going to graph the function. Very specifically, I'm using the same function. I'm going to go y1 equals 40 over x. I'm going to do x min is 2, x max is 8. And just like I did for the last graph, I'm going to put, just to start, only the numbers 2 and 8 on the x-axis. Unfortunately, in this problem, I'm going to have to put some decimals on my x-axis. They're not going to be hard to deal with because I'm using my calculator to do just about everything. So now I'd like to graph this function again. If I have the function in, I have the window at 2 to 8. If I hit graph, it has that stinking shading I need to get rid of. What I'm going to have to do is I'm going to have to clear the function, graph, get a nice clean graph, and now put the function back in. So 40 divided by x. My window is still the same window from 2 to 8, so it's still okay. And my y's are still going to be okay. So now when I graph it, I want to mark the point. So I want to mark that point. If I don't remember it, I go second calc value, type in 2, and that gives me the point 220. I want to mark the y coordinate for 8, so I type in the number 8 and hit enter, and it gives me 5. So again, I'm going to try to essentially draw now what I need to. I'm going to draw the graph. I probably didn't need to put those lines in just yet, but the graph looks something like that. This is probably a little straighter than it needs to be. And then the area that I want to find out, I'll draw it in blue this time. I don't know why. So this is the area that I'm trying to find out. And I'm going to make 4 trapezoids, add up the area of each of the 4 trapezoids to estimate this area. And the trapezoids, because they're not going to fit the graph exactly, are going to slightly, I think, overestimate the area. The trapezoids can underestimate, but in this case, I think they overestimate. So that's the goal. My ultimate goal would be to know that area. That's what I'm trying to estimate with my trapezoids. So all I've done so far is really use my calculator to create a graph of the function. You don't need to do the shading in it, but I like to do the shading just because that's the area that I'd like to know. Part B, I'm going to throw some numbers on my x-axis by taking the endpoints, the x-coordinates, and dividing them by the number of trapezoids that I need. So I'm going to go x2 minus x1, in this case over 4, because I'm going to do 4 trapezoids. I'm going to find out how far apart I'm going to put the numbers on the x-axis by going 8 minus 2, x2 minus x1, over n, which is 4. This comes out to 6 over 4, and that's really not pleasant. That's 1.5. So on my x-axis, starting at 2, I need to mark numbers that are 1.5 away from each other. So starting at 2, 2 plus 1.5 is 3.5. So the first number I'm going to put on my x-axis, well, the next number I'm going to put on my x-axis is 3.5. I need to get the y-coordinate above 3.5, so let me just go ahead and do that by going second calc value, typing 3.5. I'm rounding to 2 decimals, so I'm going to put 11.43 for that y value. So above 3.5, I get 11.43. The next number on my x-axis, I'm going to go 3.5 plus 1.5. And that's going to give me 5. So 2, that's 3.5, 4, this is 5. I need to get the y value, so let me get the y value that corresponds to 5 by going second calc value 5. And the y value that corresponds to that is 8. And then 5 plus 1.5 is 6.5. So the third number on my x-axis needs to be 6.5. Let me get the y value that corresponds to 6.5. So second calc value 6.5, and that gives me 6.15. Shouldn't have closed out that. 6.5 comma 6.15, and then 6.5 plus 1.5 is 8, and that's the 0.85 that I already had. This is not a stellar graph, and I knew that eventually my graphs were going to start being not so good. So for all the problems, I have a computer generated graph, and because this graph, I just didn't draw this part well enough. I'm going to take now this and steal it. So this is exactly what I'm just going to copy exactly what I have on that graph onto a better graph, because you're not going to see what needs to be seen, or I'd like you to see, on the graph that I drew, because it just didn't, it was just too straight. I didn't get enough of a bend, and when you don't get enough of a bend, you're not going to see the difference between the trapezoid areas and the actual areas. So this is, again, I just used a computer program to sketch a graph. This is exactly what I tried to borrow from my calculator, and it might look a little steeper because the window that I chose to draw it is a little bit different than the window of my calculators. But this is no different than this. This is this graph drawn. This is in blue is the area that I want to have figured out. So what I've done so far is I sketched a graph. I wrote numbers on my x-axis. For each x value on my x-axis, I have the y value, so I finished out the point. Now I'm going to draw my trapezoids. So my first trapezoid, I'm going to draw it connecting these 2 points and go down to there. So, and then finish out so this is trapezoid 1. And it's going to slightly overestimate the area. I kind of exaggerated that gap there, but there's a little gap. This area of trapezoid 1 overestimates. So I'm drawing my trapezoids, and I'm going to find the area of each. So I'm kind of doing D and E simultaneously, drawing the trapezoids and finding the area. So I'm going to do the area of trapezoid 1 equals, the height for each of these is going to be 1.5, because the distance on the x-axis between 2 and 3.5 is 1.5. The distance between 3.5 and 5 is 1.5. So the height for each of these is going to be 1.5. And then the bases are just the y values of each of the points. So it's going to be 20 plus 11.43. So for each of the trapezoids that I'm going to draw, 1.5 is how far each of the numbers are apart on the x-axis, and that's what the height's going to be. Base 1 is going to be the y-coordinate of the first point. Base 2 is going to be y-coordinate of the second point. And then the formula is just height times base 1 plus base 2 over 2. And I'm going to use my calculator because I don't want to do that by hand. So second quit, clear, 1.5 parentheses 20 plus 11.43 divided by 2, rounded 2 decimals. I'm going to write 23.57. So the area of trapezoid 1 is 23.57. Now I'm going to move on to the area of trapezoid 2, and here's going to be my trapezoid 2. And again, it slightly overestimates the area. It's again, my lines aren't perfect, but I'm trying to exaggerate that I'm overestimating. So for trapezoid 2, its height is 1.5. Its base 1 is the y-coordinate of that point, which is 11.43. Its base 2 is the y-coordinate of that point, which is 8, and divided by 2. So trapezoid 2, I go 1.5 parentheses 11.43 plus 8 divided by 2, and I get 14.57. So the area of trapezoid 2 is 14.57. Move on to trapezoid 3. Base is 1.5. So area of trapezoid 3, base of all these is or the height is 1.5, should I say. Base 1 is 8, base 2 is 6.15. So the area of trapezoid 3 is going to be 1.5 times parentheses 8 plus 6.15 divided by 2. That's 10.61. And then the area of trapezoid 4. Trapezoid 4 is this one. Its height is this 1.5. Its base 1 is that y-coordinate, which is 6.15. Its base 2 is that y-coordinate, which is 5. All divided by 2. Again, stick my calculator to do this for me. 1.5 times 6.15 plus 5 divided by 2 is 8.36, again rounded. So in terms of my instructions, parts, this is 4, A through D are on the graph. This is 4E. So again, A through D, sketch a graph, put numbers on your x-axis, get the y values, draw trapezoids. Part E, find the area of each trapezoid. Part F, just add up the areas together. So for 4F, I'm just going to go 23.57 plus 14.57 plus 10.61 plus 8.34. And that's going to be an estimate of the shaded area that I shaded. It's going to be an overestimate. It's not an exact because those trapezoids don't fit the graph perfectly, but 4 trapezoids fit, the gap is less with 4 trapezoids than it was 2. So let me just add these up now. So 23.57 plus 14.57 plus 10.61, 10.61 plus 8.34, and I get 57.09 as my estimate of the shaded area. And then lastly, part G I've already done because this is the same function, but I'm going to do it again. Use my calculator to get the exact area, and I'm going to round to 2 decimals again. So 4G, so the exact shaded area it should be square units, but I'm not writing those in. So I'm going to go second calc, go down to option 7, type in 2 for the lower limit, 8 for the upper limit, and it tells me that the exact area is 55.45 square units. So now I'm only off by less than 2. So the more trapezoids you draw, the better your area estimate is. On my problem 2 that did the same function using 2 trapezoids, I estimated at 61.5 because the gap between my trapezoids and the actual graph was bigger than the gap when I cut it into 4 trapezoids. If I cut it into 8 trapezoids, I'd even get a closer estimate to the exact area. So the more trapezoids I do over the same region with the same graph, the same function, the better my estimate's going to be. All right, I should probably flash your problem up there that you're supposed to be doing. You're supposed to be doing 3. So we only have a few more problems because these take so long to do. I didn't want to do a million problems. All right. So let me give problem 6 a crack. So first thing I'm going to do is sketch a graph. Then I'm going to put numbers on the x-axis, find the y-coordinates, draw trapezoids. The graph that I need to draw in number 6 is x squared plus 1, and I need to draw it between 0 and 2. So eventually, I'm going to draw my graph, and I know on my x-axis I need 0. I also know on my x-axis I need 2. I don't know what other numbers I need in my x-axis just yet, but I'm not going to worry about those right yet. So I'm going to go y equals clear x squared plus 1, and then window x min 0, x max 2. I don't think the y's need to go up to 30. I'm going to put them back to negative 10 to 10, just because that seems like a safe thing to do. Maybe it's overly safe. I'm going to make my y's even smaller. Just because this graph is so flat, I want to see some curve to it. Let me make the y's go like from negative 5 to, how about negative 6 to 6? It's probably going to help to see that the more curve I see, the easier it is to draw my picture. And let me get some points in. I want to get the y-coordinate at 0 and the y-coordinate at 2 by going second calc value, typing in 0. So I need to plot the point 0, 1. And I'm going to do second calc value and get the y-coordinate at 2. And at 2 it's at 5. This is 2, 3, 4, 5. And it should have like a curve, a little. The more curve you show, the kind of the better you can see the difference between the trapezoids and the actual area. So this is, my version of that picture. Again, it's not stellar, but it is what it is. And I'm going to draw in. It's not required, but I like drawing in. So this is actually going to be 2 now. The area that I'm trying to estimate. So I'm trying to estimate this whole area. And I'm going to do it by finding the area of 2 trapezoids and adding them together. And that's going to probably overestimate the area again. So my goal, this is what part G is going to do. It's going to find this area exactly. Again, that's not necessary to do, but I just like to do it. All right, so part A, I've sketched a graph. Part B, I subdivide the x-axis. I'm going to get some more numbers on my x-axis. I need one more number on my x-axis in interval, so I need 3 numbers on my x-axis. And I do this by going x2 minus x1 over n. x2 is 2, x1 is 0, n is 2. This is going to be 2 over 2, which is 1. So the numbers on my x-axis need to be 1 apart. I'm going to start at 0. I'm going to add 1 to get to 1. I'm going to add 1 to get to 2. And that's all I need. I need one more number on my x-axis in intervals. So I have 3 numbers on my x-axis that allow me to get 2 trapezoids. All right, so boom. Now, for each number on the x-axis, I need a y value. Well, I've got y values for those. I need to get a y value for that. I'm going to go second calc value, type the number 1 in, and I get 2. So this is going to be the point 1, 2. All right, done with step C. Part D, draw the trapezoids. First trapezoid is going to be that one. Second trapezoid is going to be that one. Maybe I could color them out in different colors. I don't know if it's going to help or not. But my first trapezoid is that trapezoid. My second trapezoid is, oh, sorry about the disgusting noise. My second trapezoid is that trapezoid. And each trapezoid is going to slightly overestimate the area, the actual area. So I draw my trapezoids. Now I'm going to find the area of each trapezoid. So I'm going to do the area of trapezoids. I'll call this one trapezoid 1, this trapezoid 2. The area of trapezoid 1. The height is this distance. This is such a lovely distance because that's 1. So the area of trapezoid 1 is the height. And then base 1 is the y-coordinate of that point, which is 1. Base 2 is the y-coordinate of that point, the right edge of that trapezoid, which is 2. Divided by 2, because it's the height times base 1 plus base 2 over 2. So my area of trapezoid 1 is going to be 1 times 3 which is 3 in the numerator, 2 in the denominator. My trapezoid 1 is going to have an area of 1.5. Again, if I'm sketching this out, 6A through D are just drawn right on the trapezoid, and this is part F. Or E, should I say. E is finding the area of each trapezoid. So A through D I show all on the graph. I don't show any side work for it. E I do off to the side. Now I'm going to do the area of trapezoid 2. Trapezoid 2 has a height of 1. The base 1 is 2, base 2 is 5. This is going to equal to 7 over 2 because it's 1 times 7 over 2. And the area of trapezoid 2 is going to be 3.5. So that's the end of part E. Found the area of each trapezoid. F, add the individual areas of the trapezoids together. So for 6F, first trapezoid had an area of 1.5, second trapezoid had an area of 3.5. So the 1.5 plus 3.5 gives me an estimate of the shaded area. So this right here is just an estimate of the exact shaded area. It overestimates because the trapezoids are, they're too tall. The last part says use your calculator, part G, to find the exact area. So now I'm going to get the shading in. So I'm going to go second calc, go down to option 7, and lower limit is 0, upper limit is 2, so I type 0 and hit enter, type 2 and hit enter, and it does my picture and it shades it exactly. The exact area rounded to 2 decimal areas, 2 decimals, that I shaded is 4.67 square units. So again, I've overestimated, but not as big of an overestimate as I had been doing, but nevertheless, it's not exact. All right, so you can give problem 5 a go. I think I'm going to, well, yeah, let me do 8 and see what happens in terms of time. All right. 8, same function, x squared plus 1, but doing 4 intervals as opposed to 2. So step 1, make a graph using your calculator. The only numbers I'm going to put on the x-axis for now are 0 and 2. And again, I'm going to have to clear this function out, graph a blank screen, and then I can re-enter it. So y equals x squared plus 1, window, x min 0, x max 2. That same window is going to work because it's the same graph. So at 0, I need to get the y. So second calc value 0. I'm going to get the point 0, 1 again. And then second calc value 2, and I get the point 25 again. And again, the more of a curve I show, the more I can see that there's a difference between my trapezoid area and my calculator area. So I can never draw that so well. So the area that I'm actually trying to figure out, I'm going to be a little bit lazy. This is the area I'm trying to figure out exactly. That's what part G is going to give me. And then my trapezoids are going to estimate this, but they're going to overestimate it again. So done with part A. I used my calculator to sketch a graph. Now in part B, I need to subdivide the x-axis by going x2 minus x1 over n. So I'm going to go 2 minus 0 over 4 is 2/4, which is 1/2. I'm going to do that at 0.5 because I'm not going to deal with fractions in this section. So on my x-axis, every 0.5 I need to plug a number. So at 0, 0 plus 0.5 is 0.5. 0.5 plus 0.5 is 1. Gosh. 1 plus 0.5 is 1.5. and 1.5 plus 1 plus 0.5 is 2. My numbers aren't spaced very nicely on the x-axis, but we just don't need to be that accurate. So I started at 0, and I just added in my head. 0 plus 0.5 is 0 plus a half is a half. Half plus a half is 1. 1 plus a half is 1.5. 1.5 plus 1 is 2. You can use your calculator if you can't do those in your head. Now for each number that I just put on the x-axis, I need to get a y, and I'm just going to cheat all day here. So I need to get this point, that point, and I already have that point. So to get the y values, I just go second calc value, type in 0.5, and that's the point 0.5 comma 1.25. And then type in 1, and this is the point 1 comma 2, and then type in 1.5, and I get the point 1.5, 3.25. So now I have all my y values in. That's the end of step C. So A, make a graph. B, put your numbers on the x-axis. C, find the y values of each point. D, draw the trapezoids. And then I have to go off my graph. So for part D, I'm making my trapezoids. So let me draw these lines in. First trapezoid. Probably I should do these with this. These are really accurate trapezoids. They're really close to my graph. Especially when I draw a thick marker, you can't even see the difference. So those are my 4 trapezoids, and you can see that I'm slightly overestimating the area. And I'm going to have a trapezoid 1, a trapezoid 2, a trapezoid 3, a trapezoid 4. I need to do each area. The height of each one of these is going to be that number. That's always going to be the height, because that's how far each one of these numbers on the x-axis are apart. And then the y-coordinates of each point are the bases. So for trapezoid 1, I'm going to do the area of trapezoid 1 equals the height, which is 0.5, times base 1, which is 1, base 2, which is 1.25, over 2. So now main screen, 0.5 times 1 plus 1.25 divided by 2, and I get 0.56. I'm rounding everything to 2 decimals. So the area of trapezoid 1 I'm estimating at 0.56. For trapezoid 2, its height is also 0.5, and then the y-coordinate of the starting point is the base 1, which is 1.25. The y-coordinate of that point, which is hardly readable, but it's 2, is the second, that's base 2, and then over 2. And so I'm going to do 0.5 times 1.25 plus 2 divided by 2, and I get 0.81. My area of trapezoid 3 is going to be 0.5 times 2 plus 3.25 over 2. And I get 1.31. And then the area of trapezoid 4, 0.5 times 3.25 plus 5 over 2. When I initially wrote this section, I had 24 problems. And then when I started shooting the first video, I realized how ridiculous that was. I mean, because it's just really repetitive anyways. Once you do 1 or 2, you can do them all. There's nothing that's really special in being able to do this. All right, so that's the end of part E. So this is 8E. This is 8A through D. Now I'm moving on to 8F, add up the areas together. So for 8F, I'm just going to write an answer and not show what I'm added together. I'm going to add up those 4 numbers, and that's going to be a number that estimates the shaded area but slightly overestimates the shaded area. So now for 8F, I'm going to just go 0.56 plus 0.81 plus 1.31 plus 2.06, and I get 4.74 square units for the estimate of the shaded area. It's overestimate. That's just, and I'm going to get the exact, I'll do that computation again, although I've already done it. For 8G, I'm going to get the exact area using the integral, or antiderivative, by going second calc, going down to option 7 that says trace, start at 0, end at 2. The exact area is 4.67. So you'll see the more trapezoids that you make, the better your estimate. With 2 trapezoids, my estimate was 5 compared to the actual 4.67. With 4 trapezoids, it's down to 4.74 as opposed to the actual 4.67. If I made 8 trapezoids, the error would even get smaller. So the more trapezoids you do, the better your estimate for the area is. But you'll never get exact. You need calculus to do the area of it. We call it an irregular shape, because the edge isn't a straight edge or a nice something from a circle. All right, so try to do 7. I think I'm going to skip doing 10, but you should do 9 for practice. There isn't anything new for number 10, and I've done 4 of these already, so hopefully that's enough, and the video's getting kind of long. So try to do exactly what I did for both problems 7 and 9, and then that will be, I'm ending here and selling you short a little bit, but hopefully you don't, that's not going to keep you from being able to do the problems. If you can't do number 9 because I didn't show you how to do 10, which is the brother problem, come visit me and I'll teach you how to do it. But it shouldn't be a big step for you to do.